Hey guys, today you are going to learn about conditional probability and independence. We have 2 slides to get through. Make sure you pause where you need to be so you can write things down and let me know if you have any questions. All right, ladies and gentlemen, today we're going to talk about conditional probability. What is conditional probability? It's the probability that one event has happened under the condition that another event has already occurred. There is a formula for conditional probability. And first of all, let's back up. How do we read conditional probability? We use this notation right here. We say the probability that B happens, and then this line right here, this means given A has already occurred. And we have that written down right here, the probability of B happening given the event that A has already occurred. Okay? Now, the formula for this is, well, let's actually just go right into the problem so you can see what this means, okay? We have peer steers. We've looked at this data already. We have people who identify as male or female, and then we have, they also say, yes, I have peer steers, or no, I do not have peer steers. So first thing that we're missing is we're missing the totals. When you see a two-way table, you should always make the totals first. So I'm going to take 19 plus 84, and that's going to give me 103. And then I take 71 plus 4, and that gives me 75. Total peer steers, 103. Total no peer steers, 75. Those people identifying as male, 19 plus 71, and that's giving me 90. And those people identifying as female, 84 plus 4, that is giving me 88. And then I take 90 plus 88, and that's giving me 178 for a grand total of how many people were interviewed or sampled. Okay, next it says, if we know that a randomly selected student has peer steers, what's the probability that the student is male? What I want you to do is I want you to underline the given in all the situations, and I want you to circle the actual question. So, if we know that a randomly selected student has peer steers, that is the given. They have peer steers. What is the probability the student is male? I'm going to scroll down here for part A, so I have a little space to write. Okay. In part A then, I am going to write it using this notation up here, okay? The probability of B, well, that is our question, okay? And then A, again, is our given. That's what's given to us. This line is, we say, the probability of B happening, given, and then this is the context of the given. Okay, so let's go ahead and write the notation out first. What is the probability? The question goes first. Look up here. B is the question. So what is the probability the student is male? Given they have pierced ears. Okay, now how do I do this? Listen carefully. There's a formula for it, but that formula can confuse people sometimes. So it's much easier if you listen to me. But before I do that, I do want to show you the formula. When I do this formula, how I figure this out, the probability of B given A, we think of this line right here. We think of that as our fraction bar. So we make a fraction bar. Then we talk about our given context. Given A has happened. Whatever has happened, okay, that goes in the denominator. Whatever has happened goes in the denominator. Whatever the question is, right here, well, that goes in the numerator. Given A has happened, so it's actually both. So the probability of both goes in the numerator because A has to have happened. So out of all of the A things that have happened, what also has happened? That's B. That's what the question's getting at. Now, if this confuses you right here, don't worry. Just keep working with me. I'll get you there, okay? So we have it written down here, okay? The probability, what's the probability that male, of pulling out a male from, if everyone's name is in a hat, what's the probability I pull out someone who identifies as male given they have pierced ears? So now the person has to have pierced ears. It's not everyone's name in a hat anymore. Remember what I said up here. Let's talk about the denominator first. The denominator is the given. So in the bottom, I need to put everyone who has pierced ears. Well, who has pierced ears? Everyone who has pierced ears is right here. The total is right there. So out of all the pierced ears people, we want to know now who of them are male. Okay? That goes in our numerator. Both pierced ears and male goes in our numerator, right? That's what the question's asking. Well, how many of these people are male and have pierced ears? There's 19 of them. So 19 over 103. Moved on. Let's try another one together. Okay? Next one. The question reads, if we know that a randomly student is selected as male. So now in the hat is all the males. What's the probability the student has pierced ears? Let's rewrite this, ladies and gentlemen. The question is now, what's the probability that they have pierced ears given they say that they are male? Now watch with me closely, guys. Watch with me closely. In the denominator, I need to put all the males. This always goes in the denominator, okay? How many males do I have? I have a total of 90. A total of 90 males. I have to pull out a male. What's the probability if I pull out a male? They also have pierced ears. So both goes in the numerator. Male and pierced ears. Well, male and pierced ears is right here again. 19. Okay, so let's recap really slow together, just in case you're a little confused. Okay, so what are we talking about? First of all, we have a new definition. The probability that one thing happens given another thing has already happened. When we're figuring out the probability, we want to put this given in the denominator. Given that has happened, what's the probability that B has already happened? So that's both in the numerator, okay? We underlined the given. We put that to the right of this line. We circled what the question is. We put that on the left of the line. Here we looked at how many people have pierced. We think of this as our fraction bar. All the pierced ears people, they go in the denominator. Out of the pierced ears people, what's the probability that they're also male? So that's both. That goes in the numerator. Okay, let's try another one. Let's do part C here. Sorry about this, guys. Okay, part C. If we know that the randomly selected student is female, what is the probability the student has pierced ears? Okay, again, we know now, ladies and gentlemen, where are we at? We know that the student is female. What's the probability they have pierced ears? I'll go a little slower if we need it. Okay, we want to know the probability they have pierced ears. Given they identify with being female, okay? Oops. Ah. Now, ladies and gentlemen, in the denominator, I need all the females. How many females do I have? I have a total 88 females. Total of 88 females. Given that they're female, they have to be female that I pull out of my basket. What's the probability that they also have pierced ears then? Okay, well, how many females have pierced ears? 84. 84 out of 88. Now remember, ladies and gentlemen, you can write this as a decimal, as a fraction, or as a percentage, okay? I want you now to practice number D on your own, so pause it. See if you can do D on your own. You're pausing it right now. Okay, if we know that the randomly selected student has pierced ears, what's the probability that they are female? Again, I want to write this out. Check your work. Hopefully you have it right. If not, you can always come ask in office hours or ask in our class as well. We know that the person has to have pierced ears. Pierced ears. What's the probability that they identify as female? Okay, that's D. That's what you should have. In the denominator then, all of the people with pierced ears. How many people have pierced ears? We know right here, it's getting messy, that it's 103. Out of those people with pierced ears, how many are female? Okay, well, out of those people with pierced ears, how many identify as female? That's 84 right there. So 84 over 103. Let's move on to our next slide. Like I said, we have 2 slides. Okay, now the next thing that we want to learn is we want to be able to prove that something is independent. In order to prove that something is independent, what we need to do is we need to prove a formula. That formula is we take the probability of one event times the probability of another event, and that has to equal to the probability that both will happen. Now remember, this intersection right here, that means both. Both happen, okay? We also want to be able to prove that 2 things are mutually exclusive. We prove that 2 things are mutually exclusive. We've talked about mutually exclusive events. You can't be a 9th grader and a 10th grader at the same time. What you would just say is the probability of A and B is equal to 0 in order to prove that 2 things are mutually exclusive. We have already talked lots about mutually exclusive. Let's just put one of those examples we've talked about. You cannot be in 9th grade and 10th grade at the same time. That is a mutually exclusive event. Now, let's go back to our previous example. Consider the event A being identifying as male, B having pierced ears. Are these 2 events independent? Step 1, let's write out the formula. The probability of A times the probability of B has to equal the probability of A and B happening at the same time. Okay, step 2, let's actually fill in what A and B are. The probability of being a male, identifying as male, times the probability of having pierced ears. Has to equal the probability of being male and having pierced ears. I'm running out of room here, okay? The nice thing about this, ladies and gentlemen, there is no given statement on here. So your denominators, they're always going to be out of the grand total. There's no condition here, okay? There's no conditional statement. So we want to go back and we want to look at our table, and let's erase all this mess that we have up here because it's hard to read now. Oops, I didn't want to do that because now I have my totals. Let's see if I can just erase in here. That's 103, so I'll rewrite that one. Okay, so let's go back. What are we looking at right now? Right now what I want to do is I want to find out the probability that someone identifies as being male. So step 3 is we're actually figuring out these probabilities. The probability that someone identifies as being male. Well, how many males do I have? I have 90 total males out of a grand total, GT, grand total of 178. 90 out of 178. Times pierced ears. Let's look at how many people are pierced ears out of 178. Well, if we look back at our table, pierced ears, there's 103. So there's 90 males out of 178. That's the probability of being male. Again, there is no given, so there's no conditional, which means your denominator is out of the grand total. Okay? Pierced ears, there's 103 people who have pierced ears. Is that equal to, out of 178 people who identify as being male and also having pierced ears? Let's go ahead and let's look at that. How many people identify as being male and having pierced ears? That's 19 out of 178. Okay, 19 out of 178. So let's figure that out now. We're going to go ahead. We'll use our calculator. When I use my calculator, ladies and gentlemen, let me pull it up here so you can see. Be really careful how you plug it in. Come on, come on, come on. As we're waiting for it to pull up, just a friendly reminder, ladies and gentlemen, when you're figuring out if two things are independent, write out the formula first, step 1. Step 2, fill in what your A and your B are, okay? A and B. Step 3, keeping in mind when you're figuring out the probabilities for each one, like we did here, right? Here and here. Your denominator is always out of your grand total. It is not like conditional probability because there's no given that is happening, okay? Only in conditional probability, when there is a given, does your denominator change. Okay, I think now that my calculator is ready to go. I am going to take 90 out of 178. Whoops, clear. So I'm going to put a parentheses there. 90 divided by 178 times 103 divided by 178. That equals 0.2926 if we round to that fourth decimal. 0.2926. So this right here equals 0.2926. Now what we have to do, guys, is it's like two separate problems. We did a problem on this side of the equal sign. Now we need to do a problem on this side of the equal sign. 19 divided by 178. That's equal to 0.1067. Whoops.